Hello guys, today I'll be showing you I'll be teaching you binary search trees, and we'll make a binary tree. We're gonna search through them, and we're gonna pretend we have a little own store called Joe Mart or whatever your name is, and add Mart at the end of it. So mine will be Joe Mart. Anyway, let me show you what a binary search tree is and how they're pretty useful. Okay, let's make this a little bit bigger. Okay, perfect. So say we have an inventory. You know what? Let me make this bigger. Say we have an inventory, and that inventory consists of um, 6 items, and those 6 items will be like, we'll have item 1 here, and then we'll have item 2, item 3, item, I'll make this longer, item 3, item 4, item 5, and item 6. Okay, and the person, if they come to your store, and they buy an item, and they scan the item in your barcode system, barcode, and pronounce that correctly. The barcode will give us a number. We'll just pretend it gives a number from 1 to 6 because we have 6 items in the store since the store is really tiny. And yes, it'll give a number from 1 to 6. And we have to figure out, okay, that 1 to 6 item, which item does this correspond to? We'll have like item 1 is chips, item 2 is TV, item 3 is a Raspberry Pi, and so on. So you can actually, this method binary search will actually work in big scale, like say you work in the let me think. You're in like Best Buy, and they have tons of items, and they have like a million items. It's a big Best Buy store, and you buy like item number 3262. And what item is that? Is that like a laptop, TV, or what is it? What's the price of it? And that's how binary search trees are handy. So I'll show you why. So to start off a binary search tree, the top number is always called a root. And in our case, the root is always usually the median. So in our case, we'll just call that 3. We'll have it as 3. And that'll branch off to, oops, sorry for that string marks. You know what? That'll branch off to the numbers. We'll have any number on the left side of the branch will be less than 3, and any numbers on the right side of the branch will be greater than 3. So in our case, we'll have 1 is less than 3. And now we look at the number 2. 2 is greater than 1, but it's also less than 3. So it'll be going on the right branch of 1. And that should be it for the left branch of 3. On the right branch of 3, we'll have 5 because it's greater than 3. It doesn't matter how you arrange these items as long as you do it in this right method. Any number less than a number on the top will go on the left branch, and the other a number greater will go on the right branch. So you have 4 on this branch, and we'll have 6 on this branch. So each like number 1 to 6 will have like a data that it corresponds to, like 6 would be a Raspberry Pi. So with that said, let's go and code this in Python. So we're gonna make a class. Oh, let me just point this out. If you don't know the basics of Python, I advise you to learn them because following the tutorial will be pretty difficult. And yeah, but if you do know the basics of Python and a little bit more than the basics, I advise you to carry on and watch this full tutorial. Anyway, so we're gonna call a class node has a value, which is number key, which is what it represents, like chips or something, and the left branch and the right branch. And we're gonna specify that self dot left is equal to the left self dot r is equal to r, self dot val is equal to val, self dot key is equal to key. And that's it. So let's create a binary tree. We're gonna have the top number as root, and that'll be, we're gonna call node, and has 3. We're just gonna use our old example, and that'll be like chips. And we're gonna just specify those left branch and right branch as none. And now we're actually gonna specify the left branch as another object of this, and we're gonna have that as 1. Gonna be Raspberry Pi, and it's gonna also have none. I could do this in one line, but that'll be pretty messy. And we're gonna have root.l and the r, that'll be actually 2. So dot l will be the left branch, dot r will be the right branch. So like dot, like l r will be left right branch, like that. Will probably make more sense to equal to 2, and that'll be a Mac. We have a weird store. Ranges from items from a MacBook to chips. Now we're gonna look at the right branch, and we'll have that as like 5, and that'll be like Slim Jim and none, and dot r dot l, which will be obviously 4. We're going back to our old example, and we'll call those the TV. We'll have it as a TV, and why am I capitalizing the O? I don't know. And finally, r dot r. So as you can see, we have created our binary tree. What should I make this? I'll make this a chicken. A plastic chicken, not a real chicken, of course. No, a toy chicken. So that's our binary tree. You could have created more items. You could actually do that. Go now and do it by all means. It won't affect any of this tutorial. So pause it. Add extra branches. And now let's actually create our search function. Search, and that's just going to take the value, like the number. You scanned it at the register, and it prints out a number. And we're just going to have another value of p, which is actually going to be like, whoops, semicolon, which is going to be like the root.r, root.l is going to be that number that it's going to, sorry, I'm not explaining this right. It's going to first start as root, and the branches will be like root.l. You'll see what I mean. So we're going to just search p, and we're going to see if the p dot the value is equal to value. We're going to say print you bought a p dot key. We're just going to return that. And else if the val, if p dot val is less than value, oops, less than, not typing right, value. Oh my god, what's up with my typing skills today? We're gonna call search with value and p dot. Now since the value number is greater than p, we're gonna go to the right branch. And if p dot val is less than, I mean the value is less than equal to value. Oh my god. We're gonna call search. Now the reason I put less than equals to is you could have numbers that are also equal to the branch, and in our case we'll just put them on the left side. Search p dot Well, but actually you cannot have two numbers because our store, you can't just like have two numbers because that will not make sense. And L. Okay, that should be it actually. So let's try this out. Call our function. Search. Say our customer bought the item number 3. That's too easy. Let's make he bought item number 4. And we're just gonna have PS root starting as root so it can branch off later on. So as you can see, it said you bought a TV. Cool. So we can also say like, okay, say he bought item number 2. What's it gonna be? You bought a Mac. Item number 1. You can go on forever. That's gonna be you bought a Raspberry Pi. Item number 5, it'll be you bought a Slim Jim. You bought a Slim Jim. Okay, so yeah, guys, that's a simple implementation of binary search tree thingamajig. And as usual, like, comment, and subscribe. And give me any suggestions of algorithms you want to do in future tutorials. And as always, Joe here, and bye.